Heyo, what's up guys? Baby Bear 4812 coming at you one more time. Today we're doing problem number 78, that's subsets. Sorry, I don't know what's happening here. Problem 78, subsets. This one's tagged the medium. I think it's appropriate. It's a popular one, and it's being asked currently by Facebook, Google, Bloomberg, and a few others. So, really good problem to know, and one that tends to make people a bit nervous. I don't think it should though. This will be a super succinct solution and piece of code, and I will also of course walk through the logic with you first as always. So the question says that we're given a set of distinct integers called nums, and we want to return all possible subsets. For you mathematicians out there, we're making this the power set. The note says that the solution must not contain duplicate, must not contain. Oh boy, it's a good thing I'm not teaching you English. The solution set must not duplicate subsets. Bam, got it. Example is 1, 2, 3, and this is the example, or sorry, this is the output we get for this example. I'll walk through that one kind of manually with you, and I think maybe we'll see if there's an easier way to check out all the possible solutions. As long as my pen isn't selected. So we've got, let me space it out this way. 1, 2, 3. All right. So we need to make all possible combinations of these numbers and, all the possible subsets, excuse me. And so when I say that, the order is not strictly going to matter. So for instance, we've got 1 and 3 here. 3, 1 would not be another answer. Okay, so we're gonna read them in order. We're not creating every possible combination or permutation or anything like that. Okay, and so what those solutions will look like is we'll have maybe, every number individually. We'll have the 1, the 2, the 3. Oops, 3. That's an ugly 3. We'll have 1, 2. We'll have 1, 3. We'll have 2, 3. And what am I missing? Oh boy, after a sorry. 1, 3, 2, 3. 2, 3, 1, 2. And I'm missing the empty set and 1, 2, 3, of course. So all 3 of them, 1, 2, 3, and including also the empty set itself. You'll notice here that we have 1, 2, 3, 4, 8 solutions in total, okay? You'll notice that we've got 3 numbers here. So what does that tell us? For every number we have, we can make 2 choices, okay? And the key to understanding how to make these subsets is in understanding that every time I look at a number, I make one of 2 possible decisions, okay? I either choose to include this number in the subset, or I choose to not include this number in the subset, okay? Every single time you make one of those decisions. So what ends up happening is you make 2 decisions here, you make another 2 decisions here, you make another 2 decisions here, and that leads you to a total of 8 decisions. To generalize beyond just the example here, it's 2 to the power n, okay? So the time that we're going to take up is 2 to the n. The space is going to be 2 to the n, or rather it will be n times 2 to the n. I'll explain why, you'll see as we walk through the examples, but we can't really get clever here in terms of making this any better. There's just like the natural reality of what it takes computing wise to solve a problem like this. So how do we now systematically think about actually putting this thing together? So like I said, now I'll kind of walk you guys through the thinking that really made it click for me in terms of understanding this problem. And what I thought about here was kind of making for any of you who've kind of taken maybe logic or predicate logic or discrete math, you'll have done truth tables. And so I'm not going to go through like a full truth table here, but the way I kind of thought about this problem was, every single step that I take, I'm going to be asking myself, do I want to include this number, yes or no? Let's say that we start out by default. I'm going to start reading this array from left to right, okay? I'm going to start reading this array from left to right, and I'm going to say yes. For every single number, I'm going to choose true. So I'm going to choose each single one of these numbers. So I get to the end, that's going to give me one combination. When I get to the end, and I can now tell myself, well, this last number, let me now make the exact same combination, but not choose this last number, okay? So I'll choose the first one, I'll choose the second, this time I will not choose the third, okay? This is gonna give me 2 combinations. If I choose these, by the way, and I'll maybe, let me kind of clear some space here, I'll delete all this. If I choose these, by the way, the combinations they'll give me are, this will be 1, 2, 3, because they're all included, okay? This one would be 1, 2. The 3 is not included, okay? I'm sorry, I missed the bit here. Get rid of that. Cool. 3 is not included, all right? And now we keep going. So now we keep kind of logically walking through this and we think to ourselves, okay, so I've toggled the 3, if you will. Let me toggle the 2 now. So we'll leave the 1 as it is. So we'll say, you know, maybe we'll leave this one out. We'll include the 3 again. And then similarly, what about the combination where I've toggled this one and we keep kind of toggling that last number now. So this would become something like 1, 3. This one would become just 1 because we are excluding both of these, okay? You follow so far? So I ask that as if you can respond, but I hope you are. If you can't, pause the video and rewind it kind of 2 or 3 minutes because again, understanding that at each one of these points you are making a decision will help us in terms of how we're going to build the code out, okay? And these are the decisions that I'm making. True represents include this number in the subset. False means do not do it, okay? Now I can tell myself, all right, let me get to actually, you know, toggling. So the 1 we left that true and we toggled 2, and then we've been toggling 3 as we go, okay? So now we got to do the 1 as well. Notice here, by the way, these are our first 4 solutions, right? It's no coincidence, that's half. I'm going to leave everything as true. So imagine kind of I've gone back to my base case and now I'm only toggling this first number. So, okay, we can do that. So it means the 1 is going to be omitted. I'm going to have a 2, I'm going to have a 3, all right? We're still going to leave this as false. And again, we go back to toggling. We're always toggling this one on and off, this last one. So we're going to leave this here, but now we're going to exclude that last one, okay? So this will leave us with only a 2. Again, we haven't had this combination. As you can see, like I'm going sequentially in a very particular order in how I'm doing this, and that's how we're going to write the code out to do it as well. This time we'll include only the 3. And then we're going to have our last combination where we toggled everything to false, and this will simply give us an empty array. So if we can find a way to write a piece of code that, not that it thinks this way, but we can represent this logic, then I think that this is the most kind of logical way to think about how to go about building a subset from scratch. Is every point of the way we're making a decision. Include this number, then don't include it. For every one of these steps, I want to say, give me a subset where this is included, give me a subset where this is not included, okay? So at this point, that's kind of all the logic that I want to do. This isn't going to be very code intensive. There aren't really any fancy data structures we're thinking about. We only got to store all these in one result array. So maybe you can start thinking about how we're going to be doing that. You know, maybe what we'll do, just maybe, is keep some sort of current array as we go and take items on and off of that as we're kind of doing these toggles, and then eventually when it kind of fills up and we have to define when we've kind of reached the end of this subset, then we put that into a result array. So that'll be the general approach, but again, let's kind of dive into the code and get our hands dirty with this. So for those of you who kind of watch my stuff enough, you know that I always like to do my error checking right off the bat. The logic we're going to write out will work even if we get an empty array. So in this case, we don't actually need to treat that separately, which is really nice. All right, it's good when that happens. So what I'll do is I'll start by actually initiating my result variable, and what I'm going to do is I'm going to have to return that after we end up filling it up. And so because we're going to be walking through here and making decisions as we go, we are going to want to make a recursive call on a function that's actually going to handle the creation of these subsets. And the way that we want to go about it is this, is we want to make this recursive function that's essentially going to be walking through with an index and pointing at items one by one and saying, okay, if I'm not at the end of the array, let's try to make a combination with this number included or not included. And then with the next number, include it, make a subset, take it out, make a subset. Keep going, keep going. Once the index gets to the end, and that'll be our terminal condition, that's where we're actually going to be saying, okay, I'm done kind of creating this subset, and we'll pop that into a result array. So what I'll do is I'll make a call here to a function up. We'll call it make subsets, okay? And we can write it in here. We'll be making subsets, and so what we're gonna have to pass in is definitely some sort of, or not some sort of, but the nums array. I mentioned an index as well, okay? So I'll call that IDX, or rather 0 we have to pass in, because we're going to start by looking at the first number. And like I said, we're going to want to keep track of the current subset that we're on right now. So maybe we'll keep that in an empty array, all right? So what that means for us is we're going to define this function, give myself a bit more space, define make subsets, and again, it'll take nums, it'll take an index, and it'll take cur. So again, now we got to define two things for recursion as always, right? One is going to be terminal condition, and the other is going to be recursive relationship. For the actual terminal condition, when do we want to stop recursing? Well, if our index gets way too big, not way too big, or just big enough, then we need to cut it off. So if our index is equal to the length of nums, or really to be on the safe side with these, it might be overkill. I like to be greater than equal to. If the index is greater than or equal to the length of nums, we're done, okay? Notice I'm not going to be returning like a new value here, but I will want to jump out of this loop or out of this recursive call on the call stack. So I'll end up returning, but you know what I'm going to want to do is I'm going to want to say, well, we're kind of done making this one, so generally I would just want to say result.append cur. And I'm going to fix this in just a second, okay? There's something I need to add on here because we're going to get a bit of funky behavior here if we leave it as is, but just kind of as a logical placeholder, I'm going to leave this code in here for just a second. It's like we get to the end, like, okay, cool, current is done. Let's throw it into the results, and let's jump out. We're done with this call. We're not returning anything. This is a void function, but we're done here. So we get that off the call stack, all right? Now, for the actual recursive relationship, I think I can get rid of these notes now. For the actual recursive relationship, we want to talk about the following. I want to make a decision, or I want to make two decisions. I need to make the decision to include the number that I'm at right now in my subset, and I want to make subsets from there. And then I want to exclude my number and then make subsets that way. I want to take my current subset that I'm at, cur. I want to append it the number that I'm on, nums at index, okay? I have chosen to include it. I now want to make a recursive call on the subset with this number included. I will call make subsets, nums, index plus 1, because now we want to make a decision for the next number, and cur. Okay? I'll get back and I'll explain this thoroughly, but just hang with me for now. I have made the decision to include this number, and I'm going to make my subsets with that decision. I'm now going to choose to not include that number in my current subset. I'm going to pop it, and now I'm going to make subsets with an active decision made to not include this number. Make subsets, nums, index plus 1, cur. The difference is that cur, here it contained the latest number, here it does not contain the latest number. Now, believe it or not, we're very close to being done. You will have one issue with this code, okay? What's gonna happen is this. Why don't I actually show you? If we run this, notice how we got all blanks here, okay? What's happening here is the following. Within Python and within other languages as well, we append the cur array or list to the result. We then systematically go back and change the list. So we append stuff, we pop it off. What we don't realize is since we've appended cur, every single instance of that, I guess even, I'm not sure that instance is the correct word, but every single time we've put cur into this results array, it will be modified, okay? So what's happening essentially is we're adding on one subset, okay? But then when we change that cur, even though we've already added it to results, it's popping off the number we have. So everything, every array in that result list now will change. And so what this means is happening is every single, the empty array, the empty subset was our final answer, and everything else was systematically changed while we were doing that as well. Quick turnaround to that, or quick fix, is just to create maybe like a temp array, and we say temp is equal to num for num in cur, okay? What that means is we're creating a new array every single time. That's where the n space comes in, right? And so why this question is n times 2 to the power n time and space is because of this right here, because we need to take the n steps to create this new array and then to actually store it in memory, all right? So that's why if we run it now, we actually should be all good. And I'm gonna submit it. I'll still give you a quick walkthrough here, but There we go. So, by the way, I ran all these on the exact same code, and this one comes out like 90 something percentile. So this isn't, I promise this isn't a mediocre solution. It's just that small variations in timing will make it seem a lot worse. So anyways, like I said, this is actually it for the code. The way that this works is it's telling us, or every single time we're telling the computer, again, make two decisions, include my number, exclude my number, okay? When we then push on to the next index, we're gonna say, I've made my decision, time for the next number to make its decision. Time for the next number after that to make its decision. We're gonna keep pushing that along. Every single index that we look at is going to make both decisions. It'll choose to include, it'll choose to exclude. I know I'm sounding like a broken record, but I wanna drill it in, okay? I really want this to make sense to you guys. Eventually, we push the index too far. The index realizes that it's way too big. It's not gonna fit in nums anymore. So we say, all right, I hear you loud and clear. I'm gonna take all the elements you have, store them in their own array, slap that array into the result, and bada bim, bada boom. That's all there is to it. So I hope you guys enjoyed this. Hope your studying is going well. If you guys have any questions, comments, concerns, anything at all, drop it down below as always. You know what to do with the subscribe button. You know what to do with the like button. You know you got to share this with your grandmother and everyone else in your family gatherings. So, yeah. Any other questions, always, guys, let me know. And I will see you next time. Peace.